So the area that I've shaded in is just 0.5 minus 0.4750. If I know the entire area above is 1/2, or 0.5, I know the area between 0 and 1.96 is, in this case, 47.5%. Then the area that I'm looking for is just 1/2 minus 0.4750, or in this case, 0.0025, or not 0025. That'd be way too low. .025, or 2.5%. And the reason why this is magical in statistics is if you're doing a 95% confidence interval, or you're doing an alpha of 0.05 on a hypothesis test, this is the cutoff value you use, 1.96. So in this case, we found the probability of being more than 1.96 standard deviations above the mean is 2.5%. Any questions about this one? So let's do another one. So let's do this one. What's the probability of being between 0.96 standard deviations below the mean and 1.01 standard deviations above the mean? So what is the probability Z is greater than negative 0.96, but less than positive 1.01? So what is the probability of being somewhere between 0.96 standard deviations above? What's the probability of being above 0.96 standard deviations below the mean, but being below 1.01 standard deviations above?
See how much time I have left. Oh, it's not doing too bad. It's actually pretty impressive that video Kurt's holding all 3 lectures so far.
So let's go through this one. Thankfully, one thing about normal distributions is the math, especially with the standardized normal, is really pretty easy. It's just either addition or subtraction versus doing a lot of complicated math here. So in this case, again, what we can do is just draw this up. So what I've drawn here is I've drawn up the area. I have 0 as my central tendency. I have negative 0.96 standard deviations here, or 0.96 standard deviations below the mean. I have positive 1.01. And so I'm looking for this area here. And what I can do in this problem to solve it is your chart doesn't actually have this directly. You do have to calculate this. But what I can do is I can say, well, I can find the area between 0 and 1.01. I can find the area between 0 and negative 0.96. And then I just add those two together. If I find the area above 0, between 0 and 1.01, that gives me 0.3438. The probability of being between the mean and 1.01 standard deviations above the mean is 34.38%. I can find this area. I look in the chart for 0.96. 0.96 is a z-score of 0.96 is associated with 33.15%, or 0.3315. So the area between 0 and 0.96 standard deviations below the mean is 33.15. And now all I have to do is add them together. And when I add them together, I get 0.6753, or 67.5%. So the probability of being between 0.96 standard deviations below the mean and 1.01 standard deviations above the mean is about 67%. 67.5%. Any questions here? So let's do another question. I mentioned here in class about potential curve. There's no definite word for a curve, but I mentioned a potential curve. So I can ask you the question. I can ask you, what is the z-score that goes with being in the upper 16%? What we can think about is maybe what I'm going to say is that if I were to curve this class, I would want approximately 16% of the students to get an A. And what I've done on your test, for example, is I was able to tell you what the mean for your class was. I was able to tell you the standard deviation. And what I'm going to do is I'm going to do that for all of your tests. So for every test, you have a z-score. Okay? How did you do relative to the rest of the class? And so at the end, what I might do is average them all out, give you like an overall z-score for all your assignments. And that's how your grade would be determined by a curve. Okay? So that's why I talked about if you're always above the average, you're in good shape for either an A or a B. Okay? If you're always right at the average, you're probably going to get that C, C plus as priority.